This is week 12, if I'm not mistaken, online learning. Grade 10s are just joining the school here, so that was for you. It would have been last week, but I'm recording it a week before. I think you guys are probably going to come a week after this, I would think. Okay, so we all just hang on there, you're almost there. So we finish with Euclidean geometry. We're still actually in the topic of shapes, but instead of proving things and calculating angles and sides, what we're going to calculate now is areas and parameters. So let me just remind you a few things in the beginning. This first exercise, which will be really a double lesson, it's pretty much a revision from last year. So let's take a rectangle, okay? If I want to calculate the area, okay? The area, just to make sure you understand, the area is this bit, it's the inside. As if you were to paint this shape, it's the amount of paint that you've put in, okay? Now the area of a rectangle, okay, is simply 7 times 12, okay? You time the side by each other, okay? So that's 70, 84, okay? Now we've got to use the right unit, so it depends on what units we have here. If we're working with centimeters, that will be centimeters square. The area will be always unit square, okay? Now what is a perimeter? Perimeter is like if you had to, let's say, fence this. This was a garden. You want to fence it. The length of the fence is the perimeter. Okay? So in this case, it's going to be 12 plus, this is also 7, isn't it? Okay? Because it's in a rectangle, opposite sides are equal. So 12 plus 7 plus 12 plus 7. Or you can see that there is 2 times 7. There's 2 7 plus 2 times 12. Okay? So that's 24 plus 14, 38. Okay? And the units of the perimeter is just the units of the side, so it will be centimeters. We're okay with that? Start very, very easy. Let's do something a little bit more complicated. Okay, so we're moving now to a triangle. Obviously, I didn't do a square. A square is just a rectangle where all the sides are the same. So the area will just be the side square. Okay? The perimeter will be 4 times the side. So I'm sure you'll figure it out without me even doing it. Okay? Now, in a triangle, we've got a different story. Let's start with the perimeter. That's a bit easier. Okay? So perimeter is just you add up all the lengths. Okay? It's going to be 7 plus 6 plus 4. You just add up all the lengths. Okay? So that will be 17. Let's say we're working with meters this time. Let's say this is all meters. How do we calculate the area of the triangle? Can you remember? So don't have a look. Just see if you can remember. Okay, good. I hope some of you figure it out. What we're going to do is times the base by the height. What is a height? Okay. Take any side. Let's say we took this side. Okay. This is the base of that triangle. Okay. So what this triangle is sitting on. Now, height is a line that goes from the apex opposite the base. Apex is the pointy bit. So you take a line here and you hit the base at 90 degrees. That will be the height for this base. Okay? Obviously, every side will have its own base. Okay? This base will have this height. This is going to be the height. This base will have, let's get another color. This base will have this height. So it all depends what height they gave you. Okay? In my exercise here, by the way, we're on page 196, exercise 1. Okay? They only gave me that blue base, the height. So I'm going to work with that. Okay? So it's going to be the base. Okay, I'll write it down. Base times height. And we have to divide it by 2. Okay, I think it's a good idea just to pause me now and copy that formula. Area of a triangle, okay, is base times height divided by 2. Base is 4 times 5, the height, divided by 2. And the answer will be 10 meters squared because we're working with meters and area is meters squared. Okay? Let's pause that again, go into something more complicated. Okay, so the triangle we worked with was acute triangle. All the angles were less than 90. But some triangles are, what's the opposite of acute? Obtuse. They have an angle, this angle here, which is more than 90. Okay? When there's an angle with more than 90, what happens is that the height to that base 2, is actually outside of the triangle. Okay? So far we looked at the height when it's inside the triangle. Sometimes the height could be outside of the triangle. Because look, triangle. So look at this base, if I go to the opposite, the opposite vertex, which is this, and I try to draw a line which is 90 degrees to the base, if I draw a line inside the triangle, it's not going to be 90 degrees, so I have to extend this line, extend the base, and then draw a line that is at 90 degrees to that extension of the base. So this is the height, 3. So the area is going to be base times height, 2 times 3 divided by 2, which is 3, and let's say we're working the same thing this way. Okay? The perimeter is simply 2 plus 4 plus 5. That doesn't change. Okay, so that is in a, what do you call it? In an obtuse triangle. Let's have a look at the 90 degrees triangle now. Okay, so in a right angle triangle, okay, the height is in fact one of the sides itself. I'll explain. Let's say we decide this is the base. Okay, this is the base. So I want to find out what's the height of that base. Well, how do we find the height? We go to the opposite vertex, which is that pointy opposite that side here, and we draw a 90 degrees, a line which is 90 degrees, hits the base 90 degrees. But this line here itself is its side. This is a side in the triangle. So if I was to draw another base, let's say here, it's not going to be 90 degrees because this is already 90 degrees. If I was to draw it outside, it will be less than 90 degrees. So the height itself is the side, which is 4. But the problem is I don't know what the base. Okay? How would I know the base? They did what? Did they forget to give me the base? No. I think some of you already figure out you just use Pythagoras. So we'll call this base, B for base, okay? And we're going to say b squared plus 4 squared equal 5 squared, right? Because side squared plus side squared equal hypotenuse squared, okay? So b squared is 5 squared minus 4 squared. That's 25 minus 4 squared. B squared equal 9, and that means b equal 3, okay? You might have also realized that, you've got that special triangle, right? 90 degrees triangle. This is 4, and this is 5, and this is 90 degrees. That must be 3. Okay? Well, it's good to do it this way. So in this case, okay, the base, remember, we're trying to calculate their area. So it's base times height divided by 2. 3 times 4 divided by 2, and that's 6. Okay? Alright? I'm not going to do the perimeter. I think you can figure out by yourself. Okay, moving on. Okay, so the trickiest questions that we would put in a test was where you don't have a rectangle or triangle or circle. It will be a combination of shapes. So I'm starting with that. That's somewhere at the top of the exercise. Okay, so you've got that little shape, and you've got some lengths, and you know that this side equal that side equal that side. Okay, so let's start with the perimeter. I know that this is 2 centimeters. Okay? Now I know this is a rectangle. I think, yeah, because they showed me that this is all 90 degrees. So this is all a rectangle, this shape, okay, without this little bump. Okay, so if this is 2 centimeters, this is also going to be 2 centimeters. Okay, opposite side of the rectangle. By the way, when you're calculating areas in shapes, you don't need to prove. It's not like in Euclidean geometry that you have to say, how do you know that this is 2? You don't need to say opposite side of the rectangle. You don't need to do that. Now, this is 2, this is also 2, and this is also 2. Okay, because they're all equal. This is 1 centimeter. Now, this is 90 degrees. So this little bump is like a rectangle itself. So this is also 2. Okay? Now, here they try to confuse us. 30 millimeters, but we have to work with centimeters. So we know that this is 3. Okay? I'm writing, if I didn't write what unit it is, that means it's centimeters. So now, to figure out the perimeter, I know that this is 2. Let's write down all the perimeters. So it's going to be that plus 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 that and plus that. Okay, that's the perimeter. It's the length all around. Imagine fence all around. Okay, so I'm going to write down 2 plus 3. 2 plus 3 plus 2 plus 1 plus 2 plus 2 plus 2, and now I've got this one and that one. I don't have that one. Okay? No, hang on. Okay, I'm told that this is also the same length. Okay, so that's also 2 plus 2. So the only only thing I'm missing is that bit, that piece. That's the last piece. Now, here you have to use the fact that this is a right angled triangle, and so I can use Pythagoras to find the hypotenuse. Okay? If I call that one x, I'm going to say that x squared is equal to 2 squared plus 6 squared. So x squared, I'm just going to do it in my head, 4 plus 36 is 40. Okay? And that means x equals square root 40. Okay? And now, so far I haven't put it in the calculator, you will have to do it in a minute. Okay? So I'm going to add plus square root 40. Okay? And guys, that I will leave you to do in your calculator. You add 2 plus 3. You don't need to do a calculator for that, right? It's 5, 7, 8. 8 plus 8, 16. 16 plus square root 40. You just need to put that in your calculator and you get the answer in decimal place. Okay? So that's for the perimeter. What about, so I know this is square root 40. What about the area? How do we find the area? So to find the area, you realize that there's 3 shapes here that we need to find the area of. First of all, it's a triangle, red and blue. Okay? Then, it's the rectangle, the big rectangle. I'm going to draw it in red. And then a small rectangle, I'll draw it in green. So it's a good idea to, before you start calculating, to kind of divide into the shape, that complicated shape. We don't have a formula for area of this complicated shape, but it's made out of little bits that you can calculate the area of. Okay, so let's start with the blue. We'll write it in blue. How do we find the area of this right angle triangle? Well, I know this is 2 and I know this is 6. This 6 is the base. Okay, so area of triangle, okay, is going to be 6, the base, times the height divided by 2. The answer is 6 centimeters squared. Okay, that's the area of that triangle. Next thing, the rectangle. Okay, area of rectangle, the big rectangle. Okay, 2 times 6. So we get 12 centimeters squared. Okay, and then finally, the small rectangle. Okay, I know that the sides are 2 and 1. To write here. Okay, so the area of the small rectangle is going to be 2 times 1, 2 centimeters squared. What do I have to do now? Correct, just add them up. So the big area will be 6 plus 12 plus 2, and that is 20 centimeters squared. Don't need the calculator for this one, right? Okay, so you've got a solved problems of triangles, rectangles, complicated questions, and now you can do some on your own. But before that, I can see I'm missing also a circle. How are we on time? No, let's do another lesson for this, okay? So yeah, what I'd like you to do is I will write down which question I'd like you to do for page 196. In the next very quick lesson, we'll go straight after that, we're going to have a look at circles. See you then.